Welcome everyone, and in this video we are going to discuss about redox reactions. And redox reactions are just oxidation reduction reactions. They are just oxidation reduction reactions. And based on that, I want us to try and dig deep into this and see what we have to understand here. First objective here, I'm going to define oxidation reduction reactions. I'm going to define oxidation reduction reactions. Next, I'm going to give examples of oxidation reactions. And lastly, I'm going to discuss how acid-base reactions, not really how metal acid reactions can be categorized as redox reactions. How metal acid reactions now. Those are the key things that I want to handle in this. Now, first I'm going to start with definition of oxidation reaction. What is oxidation reaction? Oxidation reaction can be defined in different ways in reference to oxygen and also electrons. Now, the first thing we need to know is that an oxidation reaction can be defined as a reaction involving electron loss from a substance. A reaction involving electron loss from a substance. Secondly, it can also be defined as a reaction involving addition of oxygen. Addition of oxygen to a substance. The other way in which you can also explain addition of oxygen to a substance is that oxygen is more electronegative. So when we add it to a substance, we call that an oxidation reaction. Now, oxidation reaction can also be defined as, lastly, removal of hydrogen from a substance. hydrogen from a substance. Why? Because hydrogen is more electropositive. So when you remove it, there's a way of defining an oxidation reaction from substance. Now, let me start with the most simple way. What are examples of oxidation reactions? I'm going to start with the second, which involves oxygen transfer. So we've said that oxidation reaction is a reaction that can be termed as involving gain or addition of oxygen. So if I start with a reaction such as, let me take for example sulfur, which is a solid. I decide to add oxygen to it. I will form sulfur 4 oxide. This is a gas. It's a gas. I can balance it by I simply bring in a 2 here. And I'll simply say that when I put a 2 there, in fact, I don't need to balance it. Yeah, it is balanced. I don't need to balance it because it is balanced. I can even decide to bring in another reaction such as, I can decide to bring in a reaction such as CH4 plus O2. What is going to happen? These species are going to gain oxygen and they're going to form CO2 plus CO2 plus H2O. H2O. They can also balance that by putting a 2 here. When I put a 2 there, then I'll simply put a 2 here. So these are examples of all these are examples of these ones are examples of oxidation reactions. Why? Because they both involves gain or addition of oxygen to a substance or a chemical species. Both involve addition of oxygen to a substance. Now, if that is the explanation of oxidation reaction in reference to oxygen gain or addition of oxygen, how can we explain oxidation reaction involving electron loss? How can I explain that when I want to involve electron loss? And here I'm going to start with the reaction between hydrogen and fluorine. Reaction between hydrogen and fluorine. In such a reaction, I can have hydrogen reacting with fluorine, hydrogen reacting with fluorine, then I know very well that I'm going to form hydrogen chloride. But now, I want to view this reaction in terms of electron loss. If you look at these two species, the two species I have here, fluorine is in group 7, hydrogen is in group 1, though not classified in the periodic table in the column where we have group 1 because all those are metals and hydrogen is not a metal, it is a non-metal. So group 1 elements have a tendency to lose electrons. Group 7 elements are nonmetals and they have a tendency to gain electron. So if that's the case, in this given reaction, in which I'm now having hydrogen reacting with fluorine to form hydrogen fluoride, the first key thing I need to know is how is hydrogen reacting. So hydrogen is going to go undergo oxidation half reaction. Call it oxidation half reaction. And the reaction is going to be written as, hydrogen must form two hydrogen ions, and in that process it is losing two electrons because it is the one giving fluorine electron. So this is an example of oxidation reaction. There's an example of oxidation reaction because hydrogen in this reaction here, hydrogen is forming two hydrogen ions, and at the same time it is losing two electrons. So in terms of electron loss, I can simply say this is an oxidation reaction. In terms of electron loss, that's an oxidation reaction. Now, another example I can use to show that is the reaction between zinc and copper. Reaction between zinc and copper. In a reaction between zinc and copper, I can have a situation whereby the reacting species now, most of the time, let me explain something here. Most of the time, metals and metals cannot really react, but based on the reactivity series, I can bring in a more reactive element. So what I'm going to do here, I'm going to bring a situation whereby copper is reacting with the sulfate. Because copper is too positive, for us to form sulfate, copper will give sulfates the two electron it needs to form copper sulfate. Now, this solution is always blue in color. Is always blue in color. Now, in a situation whereby now I want to react zinc plus copper sulfate, I know very well at the back of my mind that I'm going to form zinc sulfate plus copper. But what is happening here? Who has lost the electron? It is zinc that is going to undergo oxidation reaction. So zinc is going to undergo oxidation half reaction because it is the one donating electron. So what will happen here is sulfate took two electrons from copper in the formation of this. So the two electrons are returned back to copper, and copper will accept the electrons to form this. Now, after returning the two electrons, sulfate is going to be still in a deficit, is when now it is going to gain electrons from zinc. So that's why zinc must undergo an oxidation half reaction by donating an electron. So what are we going to have? I'm going to have zinc forming zinc 2 positive and donating 2 electron. So it has undergone oxidation half reaction. Next, I'm going to have a situation whereby, because I don't want the video to be long, I'm going to have a situation whereby I'm now having reduction reaction. And in a reduction reaction, I want us to define it. Reduction reaction. It is going to be opposite of oxidation. Now, reduction reaction is defined by as gain a reaction involving, is a reaction involving gain of electron. Next, that's the first definition. Second is also now is gain of electron. Now, who is gaining electron here? The electrons that were released there. So if you go back to our definition, we said reaction, another name after electrons we went to reaction involving addition of oxygen to a substance. Addition of oxygen. So what is going to be the opposite here? Reaction involving loss of oxygen. And lastly, it can also be defined as a reaction involving addition of hydrogen. Addition of hydrogen. Now, for that matter, I'm going back here. The first examples I used. I want to use the reaction between hydrogen and fluorine. Reaction between hydrogen and fluorine. So, I'm going to have reaction between hydrogen and fluorine. In the first stage, I explained that it was hydrogen who was undergoing oxidation half reaction. Now, what was happening to fluorine? What was happening to fluorine in that given reaction? Fluorine was supposed to undergo the reduction half reaction. It's supposed to undergo reduction half reaction. The reduction half reaction here is going to be fluorine. Supposed to be fluorine is supposed to accept because it is reaction involving gain of electron. So it's supposed to gain electron. So supposed to gain the two electrons. Gain the two electrons that were donated by hydrogen. Then what are we going to form? We are going to form 2F minus. So I can decide to join the two in a reaction. I can decide to join the two in a reaction. So my reaction can be, if I decide to join the two in a reaction, my reaction can be this, written this way, H2 plus F E is F2. What am I going to form? When I balance it, I'm going to form 2HF. because I'm supposed to balance it. Now, if I want to explain the oxidation nature, what am I going to say? I'm going to say the oxidation half reaction was done by hydrogen. When hydrogen did what? When hydrogen formed 2H positive, it gave us 2 electrons. Reduction half reaction was done by fluorine. Reduction half reaction was done by fluorine. When fluorine was done by fluorine, when fluorine accepted the 2 electrons donated by hydrogen to give us fluoride ion. Now, at the end of the day, I can decide to join the 2 reactions. And now, I know that in the same reaction, in the same given reaction I have there, in the same given reaction, now in my given reaction, I'm having a redox reaction occurring. So, in the next example, I'm now going to join the 2. I want to join these 2 in a reaction where I was dealing with zinc and copper, and I was dealing with copper sulfate for that matter. I want to bring the 2 together. So reaction between zinc and copper sulfate. When I have that, I can write it as zinc solid reacting with copper sulfate. Now, what am I supposed to be having? So if I have solid and this is aqueous, I'm going to have zinc sulfate forming an aqueous solution plus copper, which is a solid. So these 2 reactions can be categorized as a redox reaction. Why? I'm going to give you the explanation. Now, I said initially that in a situation where I was having zinc, now zinc undergone the oxidation half reaction to form zinc 2 positive plus 2 electrons. Copper 2 positive, that was in this, remember? That was in this, because here I'm having Cu 2 positive plus SO4 2 minus, giving me this particular compound. So that's why we are treating it as an ion. So we treat it as an ion, that given matter, then it is going to accept 2 electrons that were donated by zinc, then it is going to form Cu, which is a solid. So this one is the oxidation, is the one that is oxidation, is the oxidation, and this one is the reduction. So if I decided to join the two in the reaction of half ionic equation, I can just write it as, I can decide to write it as half ionic reaction. Now I'm going to have zinc. Let me write the subheading. If I want to write the half ionic equation, if I want to write half ionic equation, now I can decide to write it in a very easy way. Now I can have zinc, which was a solid initially, reacting with copper, two ions that were in the copper sulfate, to give me zinc, two positive plus copper, solid. So if I want to analyze this in details, I can decide to analyze it in a positive way. So zinc did us the better thing when it formed, it changed from zinc solid to zinc ion. So what did zinc do? Zinc underwent oxidation. Now copper, two ions, changed to copper metal, and this one underwent reduction. Now if that is happening, now we can simply say zinc reduces copper. Zinc reduces copper. So zinc is the reducing agent. I can simply write down here, this one is the reducing agent. Copper is the oxidizing agent. Now this one is going to be my oxidized product. And this one is going to be my reduced product. Going to be my reduced product. Now, for that matter, copper ion oxidizes zinc, and now it is the oxidizing agent. It is now the oxidizing agent. Now, the last bit which I wanted to discuss. Now, I want to discuss how we can now treat acid metal reactions as redox reaction. Metal acid reactions as redox reaction. I want us now to see how we can treat acid metal reactions as redox reactions. Now, the key thing that we have to know is that in acid metal reactions, they can be treated as redox reactions because it involves reduction and oxidation. Now, for example, I can have a situation where I'm having zinc reaction with HCl. This is always a reaction involving production of oxygen in the lab. This is how we prepare oxygen in the lab. We react zinc granules with HCl or hydrochloric acid. Then I'm going to have HCl. Then I'm going to form my zinc chloride plus hydrogen gas. This is aqueous, then this is solid. So in such a reaction, there are key things that we have to know. How can I reduce the ionic half equation? The ionic half equation involves zinc removing hydrogen from HCl or displacing hydrogen from HCl. So when that happens, I'm going to have a situation whereby zinc undergoes oxidation half reaction and it will form zinc 2 positive plus 2 electrons. This is oxidation half reaction. Now, I can also have a situation whereby hydrogen undergoes the same hydrogen that was in acid. So it must be hydrogen ion undergoes the same by accepting the 2 electrons given. Then hydrogen is going to form hydrogen gas. This is reduction half reaction. When the two are joined together, I can come up with ionic equation. Ionic equation for the whole reaction. And my ionic equation is going to be as simple as this. I'm simply going to have a situation by zinc is reacting with 2 hydrogen ions from the acid. Then same zinc is forming zinc 2 positive plus hydrogen gas plus hydrogen gas. So from there we can know which one is oxidized, which one is reduced. So this one formed this one, sorry, this one formed this. So you have to know that zinc has undergone oxidation. This one has undergone reduction. So we say zinc has lost electron, has lost electrons. Therefore, it has been oxidized. Now, hydrogen has gained electrons. Hydrogen ion, to be specific, has gained electrons, and therefore it has been reduced. So in conclusion, I can say metal acid reactions can also be treated as redox reactions. Thank you very much and have a wonderful time.